Hey everyone, today we're going to do a first project with our TTGO-T-Display ESP32, and we're going to do so with an easy sensor. This is a DHT22 temperature humidity sensor. Only one signal, and then power and ground. We'll try and take advantage of at least one input, the button and the screen, of course. And that's what we're going to do. So let's get started. The instructions of my first video in this series, getting started with the ESP32 using the TTGO-T-Display, is required to do anything in this video. Without it, nothing in this video is going to work. So click the link in the top right now to do all the things required in that video before continuing. Again, nothing's going to work until you do all those prerequisites. I'd like to solder the pins on here. I should have done it in the first video. I'm going to do it now. Put the pins in the breadboard first, and that way I'll be able to line everything up. Since there's a connector on the bottom of one side, I increased the height of the board on both sides with paper and then taped everything down. I made sure that flux was applied to all the pins. Started first by soldering all four of the corners to make sure everything was level. Followed by each individual connector. It's removed and inspected and then placed on a more desirable location on the breadboard. Let's continue. Here's the module with its three connections. We can see from the top: data, 5 volt or 3 volt, and ground. So we'll make these simple connections now. This is how I did it on the breadboard. I used the positive and negative rails on both sides for the 5 volt and the ground, but electrically this is all the same as I showed in the diagram. So now we're going to install two libraries. So we're going to go to Tools, then Manage Libraries. Once everything loads up, we're going to type into the search bar the ADAfruit Unified Sensor. We'll wait for that to come up. We have to scroll all the way down to the bottom for this one, at least on mine. We can see the library is named exactly that. Going to hit install on this one, wait for that installation to finish. I don't know if we really need this one, but it does say it's a dependency, and you're definitely going to need it in the future. Now we're going to move on to the next library. We're going to type in DHT. Several libraries are going to actually come up. The one we're particularly interested in is one labeled DHT Sensor Library, this one above, right? So we're going to install this particular library from ADAfruit. Once this installation is finished, we're going to hit close. We're done installing libraries. All the information that I needed about this library I got from their webpage. That was in the installation of the library, had the link to it. And this includes the requirement for that dependency that I mentioned before. That's why I installed it, even though we're not using it in that manner. This also tells you about all the functions that are available, and there aren't many, and not even all of them are generally used by an end user, so there's even less. It shows an example program, very simple example program, how to use that functionality. Really nothing to this. Pleasant surprise, especially for a colleague of mine I was discussing this with. This does compute the heat index, and we'll get into that later in this program. But heat index is done as well. It does simple printout for temperature, Celsius, Fahrenheit. Everything's taken care of. So very straightforward, and that's why I chose this particular library as opposed to some of the others. So we're going to create the simplest program possible based on the example to test our hardware, see how we're doing. We're going to start by including DHT.H. Next, we're going to define what the data pin is. And you're going to notice that I chose pin 17, and all the documentation is going to tell you pin 2. And I'll tell you on this particular ESP32, if you choose pin 2, you're going to have to remove this module every time you push code. So choose pin 17. Now we're going to have to define what type it is. This library supports multiple types. Ours is a 22. We're going to say that the type is DHT22. Having now defined these two parameters, we're going to create an instance of this DHT called DHT with the pin and the type. I'm going to set the serial speed to 9600 here only because the examples do for now. And I'm going to open up with a banner like they do. Then we'll execute the function begin, which sets up the pins and the pull-up timing for the device. Almost all hardware has some sort of begin function to initialize. that concludes setup. We're going to go to loop now. In loop, you definitely want some sort of delay anyway, but this device happens to be particularly slow. So we're going to add the 2 seconds like they have in the example. And we say here floating point data type T equals the return value of whatever the temperature is read in Celsius. We simply print the return value of that to the serial monitor with some sort of minimal format. I add a return line at the end of this so we could print it line after line. Notice how those F macros are used on static values and print statements. It's something you want to make a habit of, and we'll discuss it later. As upload is pressed the first time for this project, it asks to save the file. Choose a DHT project for this name. Hit save. At that point, upload immediately starts. Run through it quick, speed it up here. I'm going to open up the serial monitor, have a look. And we can see that the temperature is displayed line after line. Formatting is not perfect, but this was just an example to show that everything works properly. We can move on. Next step. Now we're going to roll the display into our existing program. We're going to add the required includes. These headers are going to go in tftp underscore espi.h as shown and spi.h. Create an instance of tft espi called tft. Notice how everything here seems to be very similar in its creation as we do tft begin. Very similar process. We're going to set rotation of 1. This is going to be landscape for our purposes. And we're going to set the text color to green and the background of the text to black. And the cursor position is going to be X position, Y position. I'm choosing the font that I chose in my last project. I'm doubling back here. I forgot to set those X and Y values, those integers. I'm going to just put those back up here now. And with the font selected and the font color and everything, I'm now going to set it to display Hello World in that location, our requisite Hello World. And I'm going to button this up. That's all we need. And now I'm going to push it. That's it. Let this upload. And we're going to have a look again at the serial monitor. And the serial monitor should have no apparent change. It's doing the same thing it always did. But if we take a look now at the actual device, we should see that Hello World is displayed in the font, in our green font with the black background, exactly as we would expect it to in the correct location. We plan out a little typesetting for our ESP32. This is going to be the screen. On the left side, we're going to write the words temperature. On the right side, we're going to write the word humidity. These are going to be static, so it's going to be very easy to write those and plan it. We'll put a little bar under that, make it look nice. And on this side, we're going to position the temperature value, and then we're going to append the C for centigrade. And on this side, we're going to have the humidity in this location, and then a modus, a percentage, and that's what we're going to do. Start bringing that drawing to reality as we start clearing up this unnecessary code we used for earlier testing. We'll remove that. We'll remove our Hello World now. I'm going to move this function call that populates T up to the top. You definitely want that created and populated before you're going to try and print the results. So it's good to put that up there. I also want to add the function call to get the humidity, and that float value is going to be H. So we're just going to put that in there now, not worry about it, but now that's done. These are going to be hard-coded values starting at 0.30 for this cursor. And because we know that this is static, I just created spaces until the Y in humidity rolled over to the next line and then dropped it back a space to give us as much space as possible between the words temp and humidity. So that was rather easy. And then I set the cursor for 0.60, which is the next line, beginning position. So that's right under temperature. And I just put a little template of 3 X's followed by a C because we're just defaulting to centigrade right now. And then 130.60, which is a second line but falls under the middle of humidity. And just put a template there of 3 Y's followed by modus. Came back over here, we're going to add a blue line, as I mentioned, a line under the headers there. So it starts at 0.35, Goes to 250/35, so a straight line running right across. That's going to be in a dark blue. So this should be our template as written on paper. But the C, or the symbol for temperature, as shown here, doesn't have a font in our current font. We're not going to be using that, so I took that out. Let's push this, and we'll see how it looks on the ESP32. And there we go. Everything looks pretty good on this template. Let's move on to the next step. So now we go in and we replace the print here, the X's, with the float T, and then we go down to the Y's that were over here, and we replace that with the float H, so that we can have those values appear on the display. We push this to the device. But things don't go as expected, because now that the output of the display is dynamic, we need some sort of way to keep refreshing the screen, or it's just going to keep writing over the last thing until everything just fills up. I'm going to add a full screen blank to the beginning of the loop. It's very simple and a bit crude, but it'll get us going for now. And you can see everything's working, and it looks pretty good in the camera. Everything's updating, looks real nice, but there's no logic governing these updates. You could almost see in the camera the screen kind of flashes every time it updates, because the whole screen redraws over and over again. There are much more elegant ways to handle this, but definitely not with a single line of code that refreshes every single time it does the loop. Be that as it may, I said I was going to try and keep this program as simple as possible. Maybe we'll come back later and redress this issue if we can. So up top in the program, I've created a new Boolean data type called use Fahrenheit. It defaults to true for this program. It happens to be that true as a parameter for read temperature makes it return Fahrenheit. So using the true value of use Fahrenheit makes it return Fahrenheit, and not having the true makes it return centigrade. So that works out really nicely using that as a parameter. Didn't take a whole lot of logic to be able to work that in. Down here, to append the C or the F to the printout, I've just used an if-else, and if use Fahrenheit is true, then right after the temperature, print an F, else, meaning, it's not true, then it's going to just print a C. And with that single Boolean value shifts everything from Fahrenheit to Celsius just by going from true to false. Now we need an effective way to change this value while the program's running. Obviously we can't modify the code and recompile it every time. So what we're going to do is we're going to use a button to change that value from true to false to change this from Celsius to Fahrenheit. I have a much better way to implement this button, but I don't have an easier way to implement it. So this is how I'm going to do it. The first thing I'm going to do is I'm going to define the names button 1 and button 2 being 35 and 0. This is on the diagram for the ESP32. This is 35 button 1 and button 2 0. These are the pins, the actual pins itself on the module. And the way that we're going to handle the pressing of this button is through an interrupt, as opposed to my preferred method, which would be a task on a separate processor. But we're going to start this off the same way, which is going to be setting the pin mode for both of them as an input. Now we're going to attach an interrupt to those pins that we've labeled button 1 pin and button 2 pin. The function that it's going to call, and what's going to cause that interrupt to happen, in this case it's going to be falling, which could be brought about by the actual pushing of the button. Correct a typo here. These attached interrupts are both the same. This one calls a separate function called toggle button 2. Again, also falling, dropping to ground when the button's pushed. These two functions, toggle button 1, toggle button 2, we can see up above here, are simple functions that I've created. They simply print to the console, the terminal, that the button 1 was pressed or the button 2 was pressed, nothing more. All the rest of the functionality of this program is left entirely the same. So now we'll just push it to the device. And if we look here, we are seeing the button code running seemingly independent from the temperature code, both buttons independently recognized. But what we are seeing is something called bounce, and this is a mechanical phenomenon we don't really think about when we deal with inputs to digital devices, but we are going to have to deal with it. So we are going to have to write a bit of debounce code to mitigate this problem. So let's do that now. We're going to create last debounce values for button 1 and 2. They're going to be long integers. We're going to declare them as 0 right out of the gates. And debounce delay is 200. This was trial and error that I arrived at 200. I started at about 50 and worked my way up. 200 seems to be a good number. It works there for these particular buttons. As for the condition here, this is a condition that kind of filters out the bouncing condition. It's basically taking millis, which is the number of the milliseconds since the program started, subtracting the last debounce value, and if that's greater than the debounce delay, which is 200, then the code is allowed to execute. If not, that interrupt event is completely disregarded. At the end of this code execution, it makes the last debounce equal to the current millis value. What executes in this example right now is the actual equation showing in the terminal, so we could see as I press the button what's actually happening with the equation, the numbers that are being compared. I did absolutely nothing for the second button. I left it alone so we could use it for comparison. Now we're going to push it to the device. We can see for every time we hit the button, we get one response, as we would expect. By comparison, for button 2, it's still very sloppy and unpredictable. And for button 1, we see the comparison that's made on the two numbers. No matter how quick I hit it, the resulting value at the end is always greater than 200. Anything less than 200 is filtered. And we can see that it works just fine when you hit the button. Sometimes you're not going to get an immediate result because the button just sets the value for Fahrenheit and Celsius. It doesn't refresh the screen. That's controlled by the delay in the loop, which is currently set to 2 seconds. So we've seen what the power of just a single bit of data has on the influence of the entire program with our use Fahrenheit. So what we're going to do now, we're creating another one called ShowTemp, and this value is going to be used to change what we see on the screen in its entirety. It's going to default to our current temperature humidity that we currently have. So in actuality, we expect to see no change on turn up. I went and made the interrupt for button 2 to look exactly like button 1 with regard to this flip-flop, except that it changes the value of ShowTemp, because it's going to do the exact same thing effectively. So we could see that right here. That's the change that was made. They are in fact identical. If we look down here in loop, I want to say that I changed the delay to 1 second because it does work and it makes the program more responsive. So I changed that right there. But the big change in loop is that I said if ShowTemp equals true, then show screen 1. If it doesn't equal true, show screen 2. And I took all of the stuff that was in loop, right, all the contents of loop, and I moved it into this new function called screen 1. So effectively, when we run this, it's going to look exactly the same as before. Nothing changed. Unless, of course, you press that button and it's equal to false, it should just make the entire screen red and just does nothing. So let's run it and see what happens. We can see that drop in the loop delay to 1 second makes this much more responsive than it was before. And if I press button 2, it changes to just a red screen as we would expect. So this is working nice. Let's do something more than a red screen with button 2 now. I'm going to go with the same design as the other screen, possibly with different colors. And because we're only going to have one value on the bottom, we'll go with a slightly bigger font if we can. And we start off with the same two calls to get the temperature and humidity. The temperature is influenced by the used Fahrenheit Boolean value. A third call to get the heat index is also influenced by the used Fahrenheit value, and it takes temperature and humidity as an argument that we just derived from before. So we see that used Fahrenheit right here is a third argument. We make the screen blank as before, kind of crude, but that's how we're doing it. And we're setting the color now to red-black, so we get a red font, and moving the cursor over, getting it to the middle. I kind of worked with this till I got it in the middle. We're setting our font as we did before, and our title is going to be heat index this time. Drawing our same blue line under it as a divider. And now we're going with a bigger font since we only have one thing to display. So we're going with a 32 of the same style font. Going with a green color as before. And we're moving the cursor again by trial and error. Found it to be around the middle. And we're going to print the heat index. And now we're going to append Fahrenheit or Celsius based again on that used Fahrenheit logic. Getting a lot of influence from that one singular bit. So we run it. We can see once again the program operates fine. The top button setting Fahrenheit or Celsius for the entire application. And now we have the bottom button which sets the mode from temperature humidity to heat index, with the top button still having influence over the whole program, whether the output is going to be Celsius or Fahrenheit. So you can see the heat index changes. And what we have essentially is just 2 bits of information that have influence over the control of this entire program, controlling Fahrenheit and Celsius and how information is displayed. So I hope you enjoyed this first short and simple project for the TTGO-T-Display. I'll be posting a link to the source in the comments below from today's program. Should you decide to expand upon it, maybe you want to try and add new features. If you have any interesting ideas, let me know what you think in the comments below. Maybe in the next video we could get into some object-oriented programming using multiple processors. But as for this video, hit that like button down below and that subscribe button for more videos. Helps me out a lot when you do. Thanks for watching.
Thanks for watching. Would you like to reply?